am Rico. Today, we will talk about thermodynamics. Thermodynamics. What is thermodynamics? It's about heat, work, temperature, energy. Thermodynamics is developed for increasing the efficiency of early steam engines.
The long boiler has a firebox at the rear where coal or oil is burned and heats up water taken from the tender. The boiler is kept nearly full at all times. The steam builds pressure just like a tea kettle, and that is gathered in the steam dome. Inside the dome is a valve controlled by the engineer. When he opens it, the high-pressure steam is let into a big pipe running to the front of the engine, where it's separated and taken down to each cylinder. A valve slides back and forth across the top of the cylinder, letting high-pressure steam in to push the piston one way, and opening on the other side when the piston moves back, letting the steam out. Each stroke of the piston pushes the rods which turn the wheels. The escaping steam and smoke on each side of the stroke of the piston create the chugging sound we all know.
Discusses the relation of heat to electricity, in which any process involving energy or electricity will produce heat.
To describe the transfer of energy. We've already described two processes as a transfer of energy, work and heat, and they're both connected to each other. As a thermodynamic system does work, it loses heat. When work is done on a system, it gains heat. So heat is converted to work, and work is converted to heat. Together, the work and heat transferred into or out of the system represent the change in its internal energy, which, as you might recall, is the total kinetic energy and potential energy of all the molecules in the system. This idea that the change in internal energy is equal to the change in work plus heat is so fundamental that it's known as the first law of thermodynamics. So we can have an equation to use for analysing problems. We write the first law like this. The internal energy, U, of a closed system is equal to Q, the heat transferred to the system, minus W, the work done on or by the system. It's important to remember that when we talk about changes in internal energy, if heat is transferred into the system, Q is positive, and if heat is transferred out of the system, Q is negative. And if work is done on the system, W is negative, and if work is done by the system, W is positive. Some textbooks will change those signs around, so it's worth keeping track of what the positives and negatives mean. Now you'll notice that the first law of thermodynamics describes only those two factors, work and heat, as affecting a change in internal energy. That's because as long as the system is closed, meaning it's isolated from the rest of the universe, there just aren't any other factors involved. The amount of heat lost by the system is exactly equal to the amount of work done by the system, and vice versa. So really, the first law of thermodynamics is just another way to describe the conservation of energy, which keeps coming up in our lessons because it's such a key principle of physics. There's always some kind of heat loss, like through friction. Even that tiny amount means that the motion can't continue forever. It will eventually run out of the energy it needs to drive the work.
Laws of thermodynamics.
Stop. Go.